Take a look at the JPA data modeling. Basically, it's going to entail creating several classes, Java classes, that represent different things in our application. We'll create maybe a user, we'll create maybe a course, a section, we'll create maybe modules, lessons, topics, right, widgets. So all those need Java, a Java class that represents this data. Here's an example of a data model represented in UML class diagrams of quite a few different types of things that we might want to model. For instance, here we can model a base class user with some faculty and students that are inheriting from user. This is a very common thing that you would do in any object-oriented language. Yes, but MySQL or SQL in general does not support the notion of inheritance, right, or generalization. So that's going to be a challenge, right? JPA makes this happen, makes this actually be able to do it. Other things that we might want to model is a one-to-many relationships, right, where you have a parent class that might be related to many other classes, many different instances of one particular class, right? For instance, examples in our particular case is that we have a course can contain many modules, and a module can contain many lessons, and so on and so forth, up until every topic being able to contain many widgets, right? So we need to be able to model this, and we'll do that using Java. Also, we can model many-to-many relationships. In this case, maybe students are enrolled in many sections. A section might have many students. We need to be able to model all these different types of relationships, right? And we'll see how we can do that today. Here's an example of a simple user that has these fields: username, password, first name, and last name. And from the look of it, there's nothing special about this class. It's just a plain old Java object. There's nothing new about this. Now, to make this a class to participate in the magic of mapping it to a table, to a SQL table, we're going to be using JPA annotations, right? These attributes here, we can say @entity, @ID. What it does is that it annotates, it decorates, right? It's a decorator pattern, right? It decorates our class saying, hey, this is going to, I want this to be mapped to a table on the in the database, right? Also, we can annotate different fields and say that we want to, I want this to be our primary key, right? So it'll be a unique identifier that uniquely identifies our instance in the database. And so let's try and do that. Let's do that for our widget, right? So we have our widget, I believe, somewhere in here. So we have Java models, and we have widget, right? We had created this widget last week just to play around with RESTful services, right? So to convert this into and map this into a table in our database, what we're going to do is that we're going to annotate it with entity. It's not finding it. Why are you not finding it? Spring Boot, blah, 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 blah. Okay, there we go. So it's adding JPA to the class path so it can resolve these dependencies. Yes? No? Maybe? Okay, there we go. All right, it found it. It found the entity as a class inside of the persistence package, right? And imported the correct class, right? And the other thing that we need to do is annotate our ID, right, as a primary key, right? And really, that's it. That's all we really need to do. Right? If we do a Maven clean install, right, it's going to parse this. It's going to identify that this particular class has been annotated with entity, right? And has been annotated with the primary key. It takes a look at that, and it fails. Wait, what? Failure, blah, 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 blah. Oh, this might be just a version of the MySQL that I'm using. Oh, yes, I remember this. Let's see. Yeah, there's an additional configuration that we need to add here in the URL. And where do I have that? Let's see. Oh, I know, in my database class. No, I don't have it in there. Do I have it? I don't. Let's see. What is the error? JDBC connection, yada yada yada. Exception, blah blah blah. Server, EDT, yada yada yada. So the server, EDT. Let's go to our trusty Stack Overflow. UTC, and there is the configuration, Unicode, blah blah blah. Okay, let's copy that. Let's add that to our configuration in our properties at the end. Unicode, blah blah blah. True, use JDBC compliant time zone, legacy, UTC. All right, let's try that again. Okay, so that looked like more promising, and it's successfully built. And you'll notice here that here it is, the create table widget. See that? Right? It created the table for us, and that's the command that was sent. Right? That's because we turned on all this logging, right? And it's typically you would not see this, right? But I think it's useful to understand, what is that JPA is doing for us in the back end, in the back. So you notice that before creating the table, notice that it did a drop. See that? So if you already had a table and you had a whole bunch of records in there and it's working, and you restart the server, it's going to drop your table. So you got to be careful, right? That's because we turned on create. We can head over to our MySQL, the workbench, and head over to the schema, and we refresh. We see that indeed now we do have a table that was not there before, right? If we open it up, right, we'll see that we have the ID and the title, right? And we can see that we can take a look at the create statement that was used. There it is. This is the create statement that was used to create this table. Make sense? All right. A couple of things here. One of the things that we might want to take a revisit is that typically the naming convention in Java is that classes are typically nouns. They're capitalized and they're singular. Right? That's the naming convention that we use in most object-oriented languages. In SQL, typically the naming convention would be that it's, well, the case doesn't matter, but typically it's also a noun. Usually tables would be nouns, and it's pluralized. Yes? All right. So we need to bridge these two divides. Let's do that. Let's head over to our Java, and let's revisit our definition for the widget. One of the things that we can do here is override the name of the table, right? Usually it will use just the name of the class, right? It'll all lowercase, and it'll just take literally the name of the class, right, as the name of the table. But we can override that by saying, hey, here's another decorator, and I want to override the name of the table. I want it to be instead widgets, pluralized, because again, that's the correct naming convention for SQL. The other thing is that the way it was created here was that we are responsible for creating the value for ID. You see that? Right. Notice that it's a primary key. We have to guarantee that whenever we insert anything into this table, that value is unique. Yes. So I'm very lazy. I don't want to have to do this. So instead, I'm going to delegate the database to do this for me. I'm going to say, hey, database, you handle that. Right. You make sure that it's unique. And we can do that by annotating this as an auto increment, right? Auto increment, okay? But again, we don't want to have to do it from here from SQL, right? That's boring. Instead, what we're going to do is that we're going to head over back to our Java implementation, and we're going to annotate this, and using the generated value annotation. The generated value says, hey, this value will be automatically compute it for you. You don't have to give it to me. You can if you want, but if you don't give it to me, if you give me a null and I store it in the database, I will calculate the unique value for you. And you can configure the strategy that you want to use. Now, different databases use different strategy. If you're using Oracle typically computes the primary key by using a sequence that creates a very long, unique sequence from where you have to pick out the next unique value. So you can establish any number of different strategies, right? If you're using Oracle, typically you would use a sequence strategy. Here we're going to use the identity strategy. The identity strategy in MySQL is implemented as an auto increment. In SQL Server, it's implemented as identity, right? Either way, right? They behave the same way, right? It automatically calculates the next unique identifier. Everybody okay? All right, let's do this again. Let's do a Maven clean install again. So again, it should drop my old table. Well, actually, no, it didn't. It only drops the one that I'm creating. So here it is. Notice that that it's dropping my widgets table, which didn't exist. It's creating a brand new, and notice that it's adding the auto increment there. See that? It's like if I head over to MySQL and do a refresh, you'll notice that now we have two tables. We have the old widget that we don't really care for, and this brand new widgets that has a different create statement. Right, notice that the auto increment is there. See that? Right, and it's pluralized. Everybody good? All right. Okay, so we're done there. What we need to be able to do now is to start actually interacting with this, right? And start inserting, updating, deleting, doing something with this. All right. So let's do that next.